Welcome to another solution video of Mechanics 1. In this question number 1, a particle of mass 8 kg is pulled at a constant speed. This is crucial, constant speed. A distance of 20 meters up a rough plane. Okay, so inclined plane is like this. So suppose it starts from here, 20 meters up plane, maybe it reached here. Okay. The inclined plane is at an angle of 30 degrees. So to the horizontal 30 degrees by a force acting along the line of greatest slope. So this is the line of greatest slope. Let's say this is the force applied. Find the change in gravitational potential energy of the particle. Okay, so gravitational potential energy, the change in PE is equal to mg final height minus initial height. Initial height, we are assuming that it is starting from the bottom of the plane, so 0. The height it has gained is this. So let's call it HF that we want, and we know that sine 30 in this triangle will be equal to the opposite, which is HF, over hypotenuse 20. So 20 multiplies with sine 30. So HF equal to 20 times sine 30, and sine 30 is half times 20 is 10 meters. So the height it gained is 10 meters. So we can write 10 here. G is known to us, it is fixed 10. Mass of this particular particle is 8 kilograms, and that becomes the potential energy gained. Change in potential energy, it is positive because final height is more than initial height. How much that will be? 8 times 10 is 80 times 10 is 800 joules. Okay, number 2, the total work done by the gravity, done against gravity and friction is 1146 joules. So work done against gravity, you should be very much clear about this. What is it? It is nothing but difference in potential energy. Otherwise, you can also write it as this work done by this force. You know, gravity has a component of the weight of the particle. This direction will be 80 newtons, and 80 sine 30 degrees is the component of the weight in this direction, and this is the work done by that weight. That's what they're saying. The total work done against gravity is the work done by this. If I multiply this force with this distance 20 meters, I'll get exactly to 800 joules again. So let's find out the frictional force. They're asking what is frictional force. So we know since this particular particle is going up, the friction will be downwards, right? And it is going at a constant speed. That's what you can say. But right now they're saying that the total work done by against gravity and friction is 1146 joule. So work done against gravity is known to us now, 800 joules. So work done by friction will be 1146 minus 800, because we'll remove the work done against gravity, that is 346 joules. And with this help we can find frictional force. Work done by friction is the frictional force times distance. Frictional force is to be found out. Work done by it is 346, we just found out. Distance is 20, so we can finally write here that the frictional force is 346 divided by 20, which is 17.3 newtons. 17.3 newtons. Let's go to the next one. Question number 2. Alan starts walking from a point O. This is Alan, and he starts from this point O. Okay, at a constant speed of 4 meters per second. That means he is not accelerating, he is not decelerating. This is the constant speed throughout along a horizontal path. Ben walks along the same path. So Ben is here, also starting from O. Okay, Ben starts from rest 5 seconds after ln. Okay, so t plus 5. 5 seconds after ln he starts. Okay, and accelerates at 1.2 meters per second. They have said starts from rest. So for Ben, u is 0, initial velocity is 0, acceleration is 1.2 meters per second square, and for 5 seconds, let's say till 5 seconds it is here. So t equal to 5 seconds from here to here, but because of this is t, he started 5 seconds later, so we can say 5 plus 5, 10 seconds after ln started. He reaches at this particular position. Okay, find how many, okay, now they have written here. Ben then continues to walk at a constant speed. So whatever speed is gained by Ben here, the same speed is maintained after this. Okay. Okay. And until he is at the same point P as Alan. So they walk forward and they meet at the same point P. From O, they started at different times, but at P, they reached at the same point. All right. Find how far Ben has traveled when he has been walking for 5 seconds. So they're saying how far is this position for Ben only Ben, okay? So we know that S is equal to UT plus half AT square. So we want to find how far. He started from rest, Ben, for 5 seconds plus half, acceleration 1.2 and t square. So s becomes, this is 0, half and 1.2, 0.6. So 0.6 times 25, that is 15 meters. So this particular distance is 15 meters till here. All right. Find the distance OP. Now they reach here P at same time. So we have to find how much difference is the distance, this one, between P and where Ben has reached. And Alan might have been somewhere here or here, we are not sure. Let's find out for this one. Because he is moving at a constant speed, it is very easy for us to find how far he went in those 10 seconds. Remember, according to Alan, 10 seconds have passed because Ben started 5 seconds later. So let's say S for Alan after 10 seconds will be speed times distance. Simple, 40 meters. So Ben is at 15 meters, but he has reached at 40 meters point, Alan. So difference between them. So distance between Alan and Ben after, so it is 40 meters Alan has traveled minus 15 meter Ben has traveled, it is 25 meters. Now onwards, the Alan will keep on moving at 4 meters per second. He's not changing his speed, but Ben, his speed is different here. Let's find his speed after 5 seconds of his travel. So let's keep the difference here. V for Ben equal to U plus AT. U is 0. He started from rest. Acceleration is 1.2. Time is 5 seconds. That becomes 1.2 times 5, 6 meters per second. Obviously, Ben is faster, then only they will reach P at the same time. So if in this, throughout this journey, he is moving at same speed of 6 meters per second, whereas Alan is moving at 4 meters per second from this point, whatever, to the P. So the difference between them is 25 meters, and they have to cover the same distance in next few minutes. So let's see the time they will take, because they are starting at the same time from different positions now. So we can say that let's say here Ben is here very far, he has to reach P, and he has taken a lead, Alan. Let's say Alan is here, he also has to reach P, but his speed is 4 meter per second, whereas Ben's speed is 6 meters per second. And they are starting from the respective positions at different speeds. So, but time they will take to reach P will be same. So distance, let's call it B. Let's call it A. So distance BP will be AP plus 25 because Alan has a lead of 25 meters. So Ben has to convert this 25 meters plus whatever Alan moves. Okay. So BP distance for Ben will be his speed, which is constant now 6, and some time we don't know. Same time will be taken by Alan. So he'll be traveling 4 times t and plus 25. So 60, this one, minus 4t, I bring this to the left side, equal to 25. So 2t equal to 25, t equal to 25 divided by 2, which is 12.5 seconds. So this is the time taken by them to reach at position P. Now, what was the question? Find the distance OP from O to P. So let's find, we already know this is 15 meter up to here. How far this distance is traveled by Ben in 12.5 seconds, right? That's what we got. Let's see. So Ben travels distance BP, right? So time is 12.5 seconds and his speed is 6. It will be how much? 12.5 times 6, 75 meters. He travels 75 meters after that time. So total distance OP will be OB, what Ben traveled first, and then what he traveled later. OB was 15 meters, we got it, plus 75 meters he travels now. Total is 90 meters. This is what he travels. Question 3. After a very long time, I'm seeing such a question, very simple and straightforward. The coplanar forces shown in the diagram are in equilibrium. Find the values of P and theta. So P and theta belong to same force. So it becomes important to get two equations in terms of both of them together so that we can treat those equations as simultaneous equations. Before we do that, since this is in equilibrium, we will have to change the forces which are inclined, like this force is inclined, this one is inclined, and P is inclined. 50 Newton is not inclined, it is vertically downwards 90 degree to the horizontal, so it will remain 15 Newton, nothing will happen to it. Let's change others to their components. So 12 Newton will become 12 cos 75 in this direction, and there will be a vertical component of this which will be 12 sine 75 degrees. So wherever is the angle, that component becomes cos, and the one on the opposite side of the force becomes sine. Similarly, the angle is here 65 degrees, so it becomes 18 cos 65 degrees, and on the other side of the force we'll have 18 sine 65 degrees. For P also we will make its horizontal component, which will be P cos theta, and obviously with 15 Newton there will be P sine theta. So these are all the components. Let me write them in equilibrium form because horizontal forces and vertical forces in opposite directions will be equal. Let's start with horizontal ones. So 18 cos 65 will be equal to 12 cos 75 on the other side plus P cos theta. Our aim is to write equation in terms of P cos theta. So let's keep it alone here on the right side, P cos theta, and write this 12 cos 75 degrees with 18 cos 65. In the process, it will become negative. That's our equation number 1. Similarly, I'll do the same process for vertical forces. We have two forces on top, which are 18 sine 65 and 12 sine 75 degrees. They will be equal to the forces on, let me write it, they will be equal to 15 plus p sine theta. Again, let's leave p sine theta here, and every other force including 15 will be on the left side. So it will become 18 sine 65 plus 12 sine 75 degrees minus 15. And 75 degrees is there. Do not confuse 15 as an angle. 15 is a force in itself. So this becomes the second equation. So whenever we have two equations in form of sine and cos, divide the equation with sine by the equation with cos. So let's do it. I will write p sine theta here, and its left side will be 18 sine 65 degrees plus 12 sine 75 degrees minus 15. And just below this, I will write p cos theta, the first equation. It should always be sine and cos in this way. Sine on top, cos at bottom. There is a reason for that. I will just tell you. 18 cos 65 degrees minus 12 cos 75 degrees. So now what will we do? We'll divide the right side by right and left side by left. Okay, so p and p will cancel. That was the purpose. Sine over cos will become tan theta, and tan theta is in our calculator. That's why I wrote sine over cos. We could have done cos over sine, which is cot, but cot is not in our calculator, so I prefer, rather we should always divide sine by cos. And let me evaluate these two and write them here. I'll use my calculator for this, and by the time I do this, I request you to subscribe to my channel, like and share this video with your friends, and I'll make many more videos like this for you. Thank you. And after using my calculator, I got numerator as 12.9 and denominator as 4.501. So if we want to find theta now, we can use tan inverse. 12.90 over 4.501. And after using my calculator, I get 70.765 degrees, which we will round off to 3 significant figures, which is 70.8 degrees. Okay, second part is to find P. So I can use any of the two equations. Let me use the equation that I made the denominator. Okay, so 18 cos, I got the value right. I got 4.501. 501 was the denominator, this one. It was equal to P cos theta, and theta is now 70.765. That's what I will write so that I get closest possible value. So both sides will divide by cos 70.765 and cos 70.765, so that this cancels out. We are left with only P, and after 4.501 divided by cos 70.765, I get 13.662. And which can be rounded off to again 3 significant figures, 13.7 newtons. This is the answer for this one. Let's move on to the next one, which is this. A particle of mass 15 kg is stationary on a rough plane inclined at an angle of 20 degrees. All right. This is it, and that's the horizontal, 20 degrees to the horizontal. The coefficient of friction between particle and the plane is 0.2. Suppose particle is here. A force of magnitude x Newton acting parallel to the line of greatest slope. This is called line of greatest slope, okay? Of the plane is used to keep the particle in equilibrium, okay? So they are saying used to keep the particle in equilibrium. That means particle normally slides down, right? Because of its weight. So what is the weight of this particular particle? It is 150 newtons. Weight is 15 kg times 10. That is 150 newton, right? Mass is 15 kg. Alright. The component in this direction which will try to bring it down will be 150 sine 20 degrees. Alright. Now we are trying to stop it. They're saying show that the least possible value of x is 23.1. When will be it least possible? When friction is in this direction. That means you apply such a little force that friction is already trying to stop it. You just add to that friction and make it stop. This is the situation when you get the least value for x. And let's substitute parts and we'll get it. So because it is in equilibrium, the force which is downwards 150 sine 20 will be equal to x plus frictional force. We know that frictional force is mu times r. So mu is known to us 0.2. R is the normal contact force, reaction force from the surface. So it will be in this direction, 90 degree to the surface. And it will be equal to the y component of 150 Newton weight, which will be 150 cos 20 degrees. So let's substitute these two values now. 150 sine 20 equal to x is to be found in, and force of friction will be mu, which is 0.2 times r. We just found r. R is 150 cos 20. Alright, so let's keep x to the right side and bring the other one to the left. So 150 sine 20 minus 0.2 times 150 is 30. 30 cos 20. And I'm sure when you put this thing in a calculator, you will get what they want, 23.1. This will be the answer you'll get. You can confirm with your calculator, please. Let's talk to the second part, which says find the greatest possible value now. Let me redraw the whole system again. So this is the inclined plane. This is 20 degrees angle and the weight is 150 newtons. X is the force still upwards, but now we want greatest. The greatest force is when you are trying to move this object up. Earlier you were trying to stop it from sliding down. Now you're trying to move it up. In that case, what will happen? That the component which was here, 150 sine 20, will be joined by the friction. Because friction always opposes the motion, and your motion is about to go up. And in that case, this value, this x force will be the sum of the two. Earlier it was the difference of the two. So the greatest value for x of x will be 150 sine 20, which is the x component of the weight, plus the frictional force, which was 30 cos 20 degrees. This is x. Just put this in a calculator and you'll get your greatest value. That simple. What I get is 79.493, which we can round off to 79.5 newtons. Let's see what's next. And this is next. A motion of a car of mass 1400 kg is resisted by a constant force of 650 newtons. So we can write Fr equal to 650 newtons. Find the constant speed of the car on a horizontal road. That's good, not inclined. Assuming that the engine works at a rate of 20 kilowatts. Power is 20,000 watt. We can't use kilowatt, okay? Always convert it to watt. And because the speed is constant. That gives a big hint. Constant speed means acceleration is zero. We know that F net force, is mass times acceleration, which is the difference of applied force minus resistive force, right? Since acceleration is zero, this F net becomes zero. So 0 equal to F applied minus resistive force, which results in applied force equal to resistive force. So we don't have to find applied force because it will be equal to the resistive force which is given to us. And power is applied force times speed. Since speed is constant, it doesn't matter where we are trying to find it out. So power is 20,000 equal to applied force 650 newtons times speed. That means V is equal to 20,000 over 650. So it will be 13 and 400 over 13 meters per second. We can, if you want, convert it to decimals. 13 times 3 is 39. 30.7565. Okay, which is almost 30.8 meters per second. Second part, the car is traveling at a constant speed again, 10 meters per second up a hill, inclined at theta degrees. Okay, where sine theta is this, find the power of the engine. We'll use the same method again, but this time it is inclined. So this time it is trying to go up. So this will be the applied force in this direction, and there will be a resistive force 650 newtons. But there is another force which will try to stop it, which is the component of the weight again. And what is the weight of this thing? 1400 kg. So weight will be 14,000 newtons. Mass is 1400 kg. So 14,000 newton will be the weight, and the component in this direction will be 14,000 sine theta. Okay, so now F net is again 0 because constant speed of 10 meters per second, that's what they're saying. So F net is 0, acceleration is 0, that means again F applied will be equal to the resistive forces, which are 2 now, not 1. So I will write both of them here, sine theta. So they're saying sine theta is 1/7. Okay, so we can write 1/7. So force applied will be 650 plus 1,400 times 1/7. 7 can cancel this, 2000. So applied force equal to 2650 newtons. Now we have to find power. Power again is applied force multiplied by the constant velocity, speed. 2650 we got as applied force. Constant speed was 10 as far as I remember. Yeah, constant speed of 10 meters per second, okay, is 10. So our power becomes 26500 watt. This is the power. See what is third part. The car descends the same hill with the engine working at 80% of the power found in part 2, or 80% of 26500. Okay, find the acceleration of the car at instant where speed is 20 degrees. That means it's variable now, so they're asking at a specific instant. First of all, we should find 80% of 26500. So these two zeros cancel out, and this will be equal to 40. 2 zeros. This is the power now. Okay, speed is given as 20 meters per second. And what are they asking? They're asking find the acceleration of the car when this is the one, okay? Mass times acceleration is applied force minus resistive force. And since it is going down this time, so applied force will be in this direction, and it will automatically come down with the help of 14,000 sine theta. Okay, this angle is theta. Only resistive force 650 Newton will try to stop it. So let's put the things here. Mass is 1400 kgs. Acceleration we want to find out. Applied force is, for applied force we'll have to calculate again. Power is applied force times speed at that instant. So speed is 20. Applied force we want to find out. Power we know, 21200. So 21200 divided by 20 becomes applied force. So that will be how much? 1060. 1060 newtons. Okay, 1060 newtons. And we know the resistive force is 850. But we had one more, 14,000. This one also part of the applied force. It's in the direction of applied force. So we will add this one. Sine theta. Sine theta is 1/7. Okay, let's do 1/7. 650 newtons. Okay, 7 cancels again. This becomes 2000. So acceleration will be 1060 plus 2000, 3060 minus 650 divided by 1400. And let's see what it is. And it comes out to be 1.72 meters per second square. Two particles of mass 1.3 kg and 0.7 kg are connected by a light inextensible string that passes over a fixed pulley, okay, smooth pulley. The particles are held at the same vertical height with string taut. Okay, so this is how it looks like. So this is one mass, this is second mass, and they are at same height from the ground. Okay, the particles are held at the same height. The distance of each particle above the horizontal plane is 2 meters. Okay, so this height is 2 meters, and the distance of each particle below the pulley is 4 meters. Total 6 meters height is the pulley. The particles are released from rest. Okay, so one of them will be heavy, one of them will be light, so they will start moving. Find the tension in the string before the particle of mass 1.3 kg. So this is 1.3 kg, this is 0.7 kg. When it reaches the plane, so it reaches this plane, which is 2 meters, right? What is the tension in the string before that? So let's do one thing. Before we want to find tension, we are not interested in the acceleration of the system yet. So let's find the tension. So because it's the same string, it will be T tension in both the strings. So first we'll focus on only this particular particle. Okay, so for that we'll have to write an equation. An equation for that will be F net equal to applied force minus resistive force. As usual, we wrote this. F net is ma. So mass for this one is 1.3 kg times acceleration of the system, we don't know what is it. Applied force for this 1.3 kg will be its weight, which is 13 Newton. Because we are focusing on only this end, we will not look at this 0.7 kg particle. So the tension is the one which will try to stop it. That is the resistive force. So acceleration becomes 13 minus t over 1.3. Same thing we'll do for the other mass, which is 0.7 kg, that one. So same equation, 0.7 A equal to applied force in this case, because this mass is going up, tension becomes the applied force because it is going in the direction of tension, and the weight of the particle becomes the resistive force, which is 7 newtons. All right. So here also we will isolate A, which will become T minus 7 over 0.7. Since both of them are A, we can equate the two equations now. So 13 minus T over 1.3 equal to T minus 7 over 0.7. Let's cross multiply this and this. 0.7 times 13 will be 9.1 minus 0.7t. 1.3 times t will be 1.3t minus 1.3 times 7 is again 9.1. Let's collect t's together. So I'll bring this 0.7t to the right and 9.1 will go to the left. So 9.1 plus 9.1 equal to 13 1.3t plus 0.7t. So 1.3 plus 0.7 is 2, it becomes 2t. So 18.2 equal to 2t, and t becomes half of this. 18.2 divided by 2, which is 9.1 Newton. This is the tension in the string before this mass hits the plane. What is the next one? The time taken for the particle of mass 1.3 kg to reach the plane. How much time does it take to reach the plane? Okay, so for that we can use S equal to ut plus half at square, since the acceleration is constant. We didn't find acceleration in the first part, but now we will need it. So let's use this equation to find acceleration. A equal to t is now 9.1 minus 7 divided by 0.7. 2.1 divided by 0.7, which is 3 meters per second square. Alright, so we have the acceleration, u is 0, and s we know that it covered 2 meters. So 2 meters equal to 0 times time plus half, acceleration is 3 times square. Okay, this is 0. So 2 equal to 1.5 t square. Let's divide it by 1.5 and 1.5 cancel out, and then square root both sides. So time will be square root of t, so not t, 2 over 1.5, which is 1.15 seconds. Okay, find the greatest height of the particle of mass 0.7 kg above the plane. So when 1.3 kg, this mass hits the ground, this 0.7 goes up out of 4 meters. There are 4 meters, right? So it reaches to this height, which is how much? 2 meters is this one. So 2 more meters. 4 meters, right? How much more it will travel? Because of inertia, it will keep on moving up, right? So they're asking how much distance it will travel. So if this is the point where 1.3 hit the ground and 0.7 is going up, now we will see what is the force acting on it. Upside, there is no force. Why? Because the applied force of 30 newtons has hit the ground. So there is no applied force. Only there will be a force which will be weight of itself. And because of the weight downwards, the acceleration will be 10 meters per second square downwards. Even though it is moving up, that means it will be a deceleration. So we want to find how far it goes above this point, right? As we want to find. And we can use the formula v square equal to u square plus 2as. So as we want to find out acceleration, we know now, u we don't know. and v we know. It will rest. It will become 0 here. It will stop after some distance. That v we know. That means u is a problem. We have to find u for this instance. And for that, we'll use the same formula, v square equal to u square plus 2as. But for the instant when 0.7 kg went up and reached this position of 2 meters above its initial position, which was already 2 meters above ground. All right. So it started from rest. U is 0 in that case. V we want to find. Right. So acceleration we found out in one of the previous parts, which was 3 meters per second square, because both the particles were connected. Acceleration is same for them. So let's find v in this instant first. So v square equal to 0 square plus 2 times, it is in the same direction, acceleration 3, and s was 2 meters is traveled, so it becomes 2 times 2, 4 times 3, 12. V square equal to 12, and this v square will become u square for the next part of this. Here is v square equal to 12, which is u square now. So now we know v square is 0, this is 12, u square is 12, plus 2 times, acceleration we know is minus 10 downwards this now, and s we want to find out. So how much it comes? Minus 20, right? 12 will come here. Minus 1 equal to minus 20 s. So s equal to minus 12 over minus 20. They cancel out. 12 over 20. In decimal, it will be 0.6 meters. So question is, find the greatest height the particle of mass 0.7 kg moves. So let's try to understand what is the greatest height. It was the plane. This mass of 0.7 kg was already 0.2 meters, rather 2 meters above ground. Then because of the mass of 1.3 kg, it went 2 meters up, and now it get 0.6 meter more above that. So total becomes 2 plus 2 plus 0.6. That becomes greatest height attained by this particle, which is 4.6 meters. Question 7. A particle P moves in a straight line like this, okay, at time t seconds. The displacement of P from O is S. So this is starting point O, and particle is somewhere here where the displacement is S. Acceleration is A equal to 6t minus 2. And they've given two conditions. When t is equal to 1, s is 7, and when t is 3, s is okay. In both cases, they have given displacement. That will be interesting. Find the set of values of t for which the particle is decelerating. Decelerating means the acceleration will be negative. In other words, when is something negative? When that thing is less than 0, it is negative. That means if I make 6t minus 2 less than 0, that will give us the time when it will be negative. Acceleration will be negative. That means it is decelerating. So let's solve this inequality now. So divide both sides by 6. That gives us t is less than 1 over 3. But we can't have a time less than 0. No negative time is possible. So our final answer will be 0 is less than, t is less than 1/3. Time is between 0 and 1/3 when the particle is decelerating. Part 2. Find s in terms of t. Okay, so to find displacement from acceleration, we can't find it directly. So what we need to do, we first have to integrate acceleration to get velocity. So we will integrate both sides. 6t minus 2 dt. So acceleration, its integration is velocity equal to 6t square over 2 minus 2t plus c. We can't find c because no condition has been given what is the velocity at different times. Nowhere there is a hint. But they have given two hints for displacement. So let's move on to displacement from here. And if we want to find displacement equation from velocity, we will have to again integrate this. So v dt will be integration of, this can cancel, 3t square minus 2t plus c dt. So displacement s equal to integration of 3t square will be 3t cube over 3 minus 2t square over 2 plus, now c is a constant, so t will be multiplied with constant when we integrate c, and we will write a new constant different from c, d, because it is integrated and we need to add an constant, and that's why they have given two situations for uh, displacement here. When t is 1, s is 7. When t is 3, this is 29. 1, 7 and 3, 29. These are the two values they have given. This is t, this is s. So we will get two equations out of them. Let's do them side by side. S is replaced by 7. That is the s, equal to 3 and 3 cancel, 2 and 2 cancel. So 1 cube minus 1 square plus c times 1 plus d. So 7 equal to 1 minus 1, 0. CD, not CD, is C only. C plus D. That's our equation number 1. Second, 29 equal to 3 cube minus 3 square plus C times 3 plus D. So 27 minus 9, 18. 29 minus 18 equal to 3C plus D. So 11 equal to 3c plus d. This is equation number 2d. Now we will subtract this equation from here. Let's write it under this. C plus d equal to 7 and subtract. 11 minus 7 is 4. 3c minus c will be 2c and d cancel. That gives us c equal to 4 divided by 2. That is the value of c. Let's find d here. 7 equal to, now c is 2 plus d. So d comes out to be 5. We got our c and d. Let's write the final equation because they're saying write an equation for displacement in terms of t. And we had t cube here minus t square plus ct, and c is 2 now, 2t, and plus d, d is 5. This is final equation of displacement. Okay, what next? Find the time when the velocity of the particle is 10 meters per second. So velocity of the particle, we know, we found the equation in between here. Where is it? Let me copy it. This one. This was velocity equation, right? So copy, and we have to find when velocity is 10 meters per second, right? They're asking for the time. So this is velocity equation, and we'll make it equal to 10. Velocity is 10 equal to 3t square minus 2t, and c we got now is 2. Okay, so let's bring 10 also to the right side. It becomes 3t square minus 2t minus 8 equal to 0, right? 2 minus 10 will be 8. So let's solve this equation now. So I will do the factoring. Minus 6t plus 4t minus 8. Okay, these are the two factors I got, 3t plus 4. If you're not comfortable factoring, just use your calculator. It can do the job for you. So this gives us 3t plus 4 equal to 0 times is minus 4 over 3, which is invalid. We can't have a negative time. This gives us t minus 2 equal to 0. T equal to 2 seconds. This is correct answer. At t equal to 2, the velocity is 10 meters per second. That's what they're asking. Yeah.